Section 5.1 is exponential functions and their graphs. This is a fairly short lecture, only 2 videos. Start with a definition. Basic exponential function is a function of the form f of x equals a to the x, where a is in the interval 0 to 1, union 1 to infinity. So it's going to be in either between 0 and 1 or between 1 and infinity. A is called the base and x is called the exponent, hence the name exponential function. So remember, a power function has a variable in the base and a constant in the exponent. An exponential function has a constant in the base and a variable in the exponent. So the variable in the exponent is the important thing. There are other things like x to the x, which is neither exponential function nor power function. So note, I just wrote this out for you, so you have it on the PDFs. Base of an exponential function is a constant and the exponent is a variable. So question, why is a not negative? Well, so it says that a is between 0 and 1 or between 1 and infinity. So that's saying it's not negative, it's not 0, and it's not 1. So the first question is, why is it not negative? And that's because we want the domain of f to be all real numbers and the range to be contained in the real numbers. And if a is negative, for example, we would have, if it's negative 1, for example, then f of 1/2 equals negative 1 to the 1/2, which is the square root of negative 1, which is I, which is not a real number. So we don't want to use negatives for the base a. Then why doesn't it allow a to be 0? Well, if a was 0, then f of 0 equals 0 to the 0, which is not a real number. That's what we call it indeterminate. It's really bad. 0 to 0 is worse than dividing by 0. Also, for x not equal to 0, f of x would equal 0 to the x, which is 0. So basically, f of x equals 0 to the x is the x-axis with the origin removed, which we don't want to call an exponential function. We want to call it a line with a point removed, right? So question, why is a not equal to 1? Notice that a is between 0 and 1, and between 1 and infinity, but not including 1. Why isn't 1 included? Well, if a was 1, then f of x equals 1 to the x is the constant 1. It's a constant function, and we call that a constant function, not an exponential function. Okay, so this is not the domain here. A, it says a is in 0 to 1 or 1 to infinity, not x. X, the values of x would be the domain. A is just the values of the base. It's a constant for each function. So down here at the bottom, I've got any quantity that changes by a constant factor, that is, you're multiplying by some constant over time, is described by an exponential function. So if it's doubling every hour, it's exponential. If you're getting half of it every hour, it's exponential. If you're multiplying by 1.6 every hour, or every time x goes up by 1, you multiply by 1.6, multiply f of x by 1.6, that's an exponential function with base 1.6. It just kind of goes like that.